Good afternoon, everyone, and welcome to this fifth episode of Space Connect, ITU's webinar series exploring the future of space telecommunication. I'm Thomas Gonzalez Roberts, the academic in residence here at the ITU, as well as an incoming assistant professor of aerospace engineering and international affairs at the Georgia Institute of Technology in Atlanta, Georgia, where I lead a research portfolio focused on international coordination, sustainability, and security in outer space. Today's topic, space safety, sits at the heart of a growing global conversation. As the orbital environment becomes more crowded and contested, we're seeing increased recognition that safety and sustainability are deeply interconnected in the domain. In fact, recent outcomes from WRC 23, including the enhancements to non-GSO coordination and equitable access, reflect how ITU members are now explicitly mandating the organization to help build a sustainable space environment through evolving regulation. Resolutions like Resolution 218 and ITU-R Resolution 74 instruct the ITU to not just manage radio frequencies and orbits, but to do so with sustainability, resilience, and equity in mind. This marks a significant shift. Space sustainability is now a formal, shared responsibility across this international system. To help explore what this means in practice, I'm thrilled to be joined by three guests whose work spans systems, sectors, and continents. Please join me in welcoming Dr. Shan Yap. She is an assistant professor of innovation and global governance at Utrecht University and a principal investigator of the ERC-funded Planet Stewards Project. She's a pioneer of the concept of Earth-space sustainability, and her work spans policy, transitions, and international governance. Sundar Rajan brings deep technical expertise in avionics and electronic warfare, having led foundational work in India's combat aircraft development and served as director of DRDO's Defense Avionics Research Establishment. His leadership in indigenous technology development and systems integration has helped shape India's aerospace capabilities over several decades. And lastly, Emmanuel David is executive director of eSpace at the EPFL Space Center, where she leads a growing interdisciplinary effort to embed sustainability into research, education, and real-world partnerships. With over a decade of experience in space transportation across academia, agencies, and industry, she now oversees EPFL's Sustainable Space Hub. I'm excited to have these guests together because they represent a diversity of academic thought. My position at the ITU is the first of its kind and a representation of the organization's reach to the international academic community. Often in partnership, the ITU is a great resource for data describing the mission plans for states around the world, how they would like to use the space domain. And how you'd like to use the space domain is often different than the practice with which you really use it. So together, the guests and I will explore how their diverse backgrounds inform our understanding of safety in orbit and what it will take to build safer and more sustainable systems in the future. Let's get started. I wanted to give each of the guests an opportunity to introduce themselves. And if they could, help us by defining a few terms. I recognize that the description of this episode describing space safety, sustainability, and security could benefit from some disambiguation. So according to each of you, I'm curious where you think these concepts align and where they diverge in your own work. But please do share a bit more about yourselves for our diverse audience calling in from all around the world. We'll start with you, Shen.
Thank you very much, Thomas, for the very kind invitation to this panel and also to our ITU colleagues. It's a pleasure to join you and Sounder, and of course, Emmanuel, my very close colleague back at EPFL and collaborators by now. I am Xiao Shan Yap, or Shan for short. I'm an assistant professor of innovation and global governance at Utrecht University in the Netherlands. So as Thomas has shared, I lead a project project, a Planner Stewards project on Earth space sustainability, funded by the European Research Council. And I also call it the EU Cost Action Focus Project, Futures-Oriented Governance of Outer Space. So our central argument is that the rise of these space activities today are increasingly causing new environmental and social challenges. But the mainstream paradigm that we have towards sustainability is increasingly limited to deal with these challenges. When we talk about challenges, we talk about environmental and social challenges. Why? Because the mainstream sustainability paradigm still puts Earth at the center, that outer space is positioned as an external environment, an external entity. So it remains quite disintegrated with the sustainability challenges that we are dealing with back on Earth. So with that, with my colleagues, we put forward this idea of Earth space sustainability, which essentially provides an expanded system boundary of analysis to more proactively consider the positive and negative interactions from space activities back on Earth. And we take into consideration the environmental and social dimensions of these challenges. So we argue that with this Earth space sustainability idea, we adopt a more integrative approaches to how we conduct space activities and how we regulate or govern space activities. In both of the projects, we adopt a broader approach to what sustainability or Earth space sustainability should mean. For example, in the context of the EU Cost Action Focus project, we have three major pillars with three international working groups. So each of these working groups or pillars focuses on one dimension of space or Earth space sustainability. One of them is equity or justice. The second one is security or peace. And the last one is the environmental integrity. So recently we conducted a stakeholders workshop in collaboration with the EPFL Space Center and the Secure World Foundation in Lausanne. So we gather stakeholders and experts, and we jointly discuss to what extent the existing governance instruments, the space governance instruments, approach these three pillars of sustainability dimensions. And we realized that different governance instruments from inter-stakeholder levels to national/regional, as well as intergovernmental level instruments, interpret sustainability very differently, and they have different order of priorities to the three pillars of equity, peace, as well as the environmental integrity of sustainability. So coming back to today's discussion, these three dimensions of safety, security, and sustainability, because we adopt a broader approach to sustainability, we see all these three dimensions as deeply interconnected. For example, if there is not a secured and peaceful futures of space, it comes at the expense of social equity or justice. Therefore, if there's no secured futures, there is no sustainability. And of course, when we look at space safety, for instance, so space safety to us is something more easily distinguishable from this broader sustainability approach. Because from our perspective, safety focuses a lot on the day-to-day operations of satellite activities and to ensure the continuity of these economic services and operations. So we can see safety, space safety, as a form of resilience to the challenges. And therefore, it can be an indicator or factor to the broader sustainability idea. So perhaps my last point here is that the central message that as a social and political scientist is that space sustainability is a socially constructed concept. It is socially and politically constructed. So as scientists and researchers, our role is to be able to distinguish these different versions of the constructions of space sustainability, debate about them, and bring them into the discussions for comparisons. When we are conducting research, try to have more action-oriented research that bring policy recommendations. So when we are providing policy recommendations, we have to, as I said, proactively bring in these different constructions and consider which one of them or which combinations of them will actually be more ideal in the future. And from there, propose recommendations that can make changes in terms of the day-to-day practices or the business as usual. So I will stop here. Thank you, Thomas.
Thank you, Shan, and I appreciate some of those remarks, especially those describing the nature of the social construct of sustainability in space. I might add that I find it to be a bit challenging to measure the sustainability of something. That's one topic that I know Emmanuel, another guest on the panel, has a lot of experience dealing with, which is a departure from those other two terms. I think space mission operators would quite easily be able to describe or measure when they're lacking space safety, such as in an environment in which they face inadequate access to the radio frequency spectrum, perhaps when they're susceptible to electronic warfare. And that's perhaps a strong segue to our next guest, Soundar. If you may, please take a moment to introduce yourself. If you could share an example of a past project, either in your experience at DRDO or in academia now, that touches on some of the themes of today's conversation. And if you'd like to further disambiguate between those three terms, space safety, sustainability, and security, as you think it may be pertinent to our audience, please do so now. Thank you.
Thank you. Thank you, Thomas. Space safety is a result of measures aimed at preventing malfunction. So for something to be safe, you need to design it and develop it. For example, measures such as good system design with built-in redundancies for safety critical functions. I don't know, in India, we have the transport department, road transport department, and one of the most important official there used to be called a brake inspector. The brake inspector's job is to see that, inspect your brakes and certify that those brakes are working. He is not bothered about whether your car is running efficiently, all those things. Of course, now they've included pollution as one of the measurement points to allow the car to run on the road. But brake is the most important thing. That means the safety is the most important thing in any vehicle that shares a public resource. In this case, the vehicle is a road. For the car, it's the road, but for our satellites and other spacefaring vehicles, it is space. Now, all these years, people have been having so much of space and so few satellite vehicles. There is no conscious movement towards ensuring safety, basically because the only thing that will affect, if something malfunctions, it affects only the mission. And the mission failure is going to affect only the guy who does the mission. It doesn't affect others. But now it's changed. If your satellite is stopped functioning, it doesn't matter to others as long as it stays in its course. Moment that part of the satellite that controls the trajectory malfunctions, and you deviate from your course without informing, and you get into collision with others, you are in trouble. You're causing trouble. So safety is not only for your own, which, of course, if you are not safe, you're not sustainable. You need to be, these three are linked: safety, security, and sustainable. So it is very important that we build safe systems with particularly throughout the design phase, development phase, etc. Security, of course, as I said, if you want to be safe from a possible collision from a fellow satellite, maybe intentional or unintentional, you need to have some built-in functions to protect yourself. This brings us to security as well. Security in terms of We can discuss it later also, more on cyber, etc., and encryptions so that you don't get into problems of being sort of conned into uh, measures that you are not intending to do. Like, for example, spoofing that usually happens. If you have, for example, a GPS receiver on board for some function and somebody is spoofing it, you can be in trouble. So it is very important to have safety, security, and it will automatically lead to sustainability. Sustainability is not a separate topic. If we can address safety and security together, we can definitely uh, arrive at sustainability. I'll stop here. Thank you.
Thank you, Rajan. And a few of the comments that you shared preview some of the topics I hope to discuss together with the panel. Specifically, I hope to have some time to further interrogate that analogy about checking brakes. As the outer space domain is an inherently shared environment where our governing mechanisms often lack the ability to enforce any of its rules or verify that those rules are being followed. So I might challenge you later to think through. I'll give you this chance to do it now, I suppose, as well. Who are those verifying agents? What responsibilities do they have? And if we find space sustainability advocates up and down the space development ladder, what are their responsibilities to promote some of those ideals with the mechanisms that they have, perhaps at the state level? Which brings me to a good preview for those who are calling in. This is my first time hosting the ITU Space Connect webinar, but I've had the privilege of watching before, and I know that our audience is quite diverse. So we welcome you if you're calling in as a national telecommunications regulator, if you are an academic, perhaps a student studying one of the many topics that feeds into interdisciplinary space studies, or you're learning about these topics for the first time in another capacity, we very much welcome you and thank you for joining us this afternoon, this morning, this evening, wherever you're calling in from. And I'd like to take a moment to introduce our last guest, Emmanuel. Please take a moment, if you could, to share a highlight from your rich space sustainability research portfolio at EPFL. If you think some of your colleagues on the panel are a series of definitions for those three terms, could use a few footnotes or asterisks, now is your time to share those comments as well.
Okay, thanks. Thanks a lot. So, Emmanuel David, I'm here executive director at the EPFL Space Center. EPFL is the Swiss Institute of Technology in Lausanne, Switzerland. And we have a strong heritage on space sustainability and notably ClearSpace, which is the first European company that was awarded a contract by the European Space Agency to remove a space debris, is actually a spin-off from our space center. We launched 2023 the Sustainable Space Hub, and it's a competence center that aims for the long-term use of outer space and is built around three pillars: measure, understand, and act. So as you understand, we are a technical university, so we really want to understand how to measure space sustainability, but also develop technologies for space situational awareness in order to better understand the space population, but also other aspects, I would say, of the impact of space mission on the Earth and space environment. So in that aspect, we looked also at the adapting methodologies such as life cycle analysis for space missions. Then to act in order to develop, I would say, more sustainable missions, mission design also, but also to provide evidence for decisions makers when they need also to develop the policies or take decisions. So that can go in both ways, so that you better understand also the space environment and the space industry in the lens of space sustainability, and after also when you need to enforce what you're doing. So I think it's before and after. And so then it can look back and then what do you need to measure, what do you need to understand in order to act. So we look mostly, when we talk about space sustainability, you have sustainability from space, so what space can do for Earth sustainability. You have sustainability in space, so what we would think when everyone talks about space sustainability, like the space debris, and maybe, but it's also larger, and sustainability for space, so the impact of the space industry on the Earth and space environment, such as during the, mission design, the production, transportation, and launch, and what are also the impacts, for example, during the launch, the impact on the layers of the atmosphere, and also during re-entry, for example, the burning of the objects. So we focus more, I would say, on what we call sustainability for space and sustainability in space, and less about the socio-economic benefits of space for the Earth environment. Even though it's a huge topic and it's also very relevant for what we are doing. In addition, we've been working now over 5 years with the Space Sustainability Rating. So I will say maybe a few words. Space Sustainability Rating has been initiated by the World Economic Forum in 2017, 2018. And then during that time, there is a consortium with the European Space Agency Space Debris Office, UT Texas at Austin, MIT Space Enable Group, and Bryce Technologies that work in developing a rating system to assess, I would say, level of sustainability of space missions. And then when they had the product, they looked also for an entity to launch the operation, and that's where EPFL came in the game. And we incubated the project and created now 3 years ago the Space Sustainability Rating Association. So what is the rating? The rating is a modular system, transparent for operators to assess the level of sustainability of their mission. And there we mostly look at what we call the in-space sustainability. And we look at what are the impact on the space environment, responsible also measures, data sharing, I think it's important, compliance to standards and regulation, as well as the capacity to be compliant to future external services such as in-orbit servicing and space debris removal. And there with the rating, it offers one definition of space sustainability, but we know it's and people on the panel will agree, it's a very complex topic. So that would be, I would say, the two, I would say, lens I wanted to mention about the work we've been doing here at EPFL and supporting with the Space Sustainability Rating Association. Now, answering to your question about space safety, space security, and space sustainability, I would like to mention a paper, a presentation that was presented at the European Space Debris Conference earlier. It was in April 2025, presented with Darren McKnight from Leo Labs, Victoria Sanson from Secure World Foundation, Audrey Schaeffer from Slingshot Aerospace, and Marco Aliberti from the European Space Policy Institute that looked actually at those three topics. I really wanted to highlight that it's their work, and it's interesting because you have a US, Europe, SSA providers, and also academia that looked at that. And they propose a definition where they mentioned that space security is, in terms of time frame, is really looking at, you need to act in terms of hours, days, week, or months. And it's really to retain the ability to operate through military and national security events by identifying and characterizing threats to enable deterrence and mitigation. So that's the definition they propose. Then they link it also with space safety, which is linked also with the notions of that you need to have space traffic management, and in a time frame which is a bit longer in terms of days, weeks, and years. And really, with space safety, you need to manage collision risk for a space system to ensure mission reliability and not adversely affect the others. So maybe with safety, you also have the concept of responsibility, but safety also for mission operators and spacecraft designer is also to avoid that your system breaks up, and you have a dedicated workforce on that. And finally, space sustainability, and there they talk more about the active debris removal, and in the time frame they look at years, decades, century. And when we talk about space sustainability, we see also in the technical community those long-term evolution of the outer space population, and they look at controlling space objects population to avoid cascading collisions that could curtail space operation. So my personal opinion is, with the space sustainability, they might have limited to one facet of it, and it's a much more complex. And I think if you look at a holistic manner, you need also to consider the other pillars that I have mentioned, but also more the socio-economic aspect of it that is also covered by Shan's research. So that would be, I would say, my proposition as an intro on those three different terms.
Thank you, Emmanuel. And I think that it's very academic of you. Sometimes we can't resist but to drop in like a footnote, even verbally. So thank you for recommending those readings.
Yeah.
Who are watching this webinar later, there may be a place online to find some of those recommended readings on the Space Connect website. Emmanuel mentioned, I think what's, to me, one end of a spectrum when it comes to communicating your intentions in the space domain. If you are a mission operator who's interested in pursuing a space sustainability rating from the SSR Association, perhaps you might be a particularly communicative mission operator, which I would argue represents from the beginning origins of spaceflight. In the early, the dawn of the space era, really, which the space policy community often describes as the first space age, secrecy, or the attempt of obfuscating mission operations in space, was the name of the game. And to instead be sharing your intentions and even your capabilities, to me, is a representation of a departure from space security norms. And so I think it's interesting how several of you in your introductions mentioned that these three topics are interconnected. And I would agree that they very much are. And you cannot have space sustainability. You cannot have space sustainability without space safety. I agree with some of those series of logic. Remarkable to me, however, that it's often possible to pursue concepts of space security that directly jeopardize the other two. Meaning, in real examples of states and non-state actors damaging or degrading space assets from adversaries around the world, they're deploying jamming and spoofing technologies, like Rajan mentioned in his opening remarks, which directly contribute to harmful interference in the radio frequency spectrum, one of the foundational components of long-term space sustainability, as described in the United Nations Space Sustainability Guidelines, and also the foundational treaty of the International Telecommunication Union. In those cases, I want to just draw perhaps some attention to that innate challenge. I can maybe drop a footnote myself if the audience members would like to read more about active threats to space systems. I encourage them to read into the work of my colleagues at the Secure World Foundation and their Global Counter Space Capabilities Report, or those at the Center for Strategic International Studies and their Space Threat Assessment series. But I wanted to sort of give the speakers a chance to sort of respond to that interrogation of mine. Those cases in which to pursue a more secure space environment, perhaps when you ask the United States Space Force or its adversary military organizations around the world, can you still have space safety or long-term sustainability? Rajan, perhaps I could start with you since I mentioned directly electronic warfare. You may be muted, Rajan.
It's good that you mentioned the US Space Force. This also connects with your earlier question of how do we follow the concept of brake inspectors in space? What is the architecture for that? The issue is, in order to, first of all, survive things like cyber attacks, as well as now we have got a new concept called cyber electronic warfare attack. That means if there is air gap, you use electronic warfare to deliver the cyber issues into the system. So we definitely need a force. For example, as a police inspector on the road, a traffic policeman, we need a policeman to do certain amount of control in space. So the concept of US Space Force, or I would even call it, I'm just running my imagination run, right? So basically, United Nations Space Force, whose job is to police, whose job is to identify. The capability of the US Air Force in terms of observing from space, including the amount of SSA capabilities the US has got, is unbelievable. And others are not doing it basically because the lack of technology and lack of resources like money. So US is in an excellent position to be able to see each and every vehicle in space, quite however small they are, and they are able to track even they are able to even find the intent of these vehicles, who change their course and whatnot. And also they can even have ELINT satellites which pick up if somebody is intentionally jamming other countries' satellites. This can also be picked up by ELINT satellites of the UN Space Force, I would say. I'll call it UN Space Force. Once it has all these facilities, then it is also possible with the capability like the space plane, or highly maneuverable with high delta V capability, the space vehicle. Like as usual, the traffic police is supposed to have faster cars than the others so that he can overtake and stop them. In similar situations, we need to have very high performance vehicles in space to maintain law and order in space. I think it's a must in order to do this. So electronic warfare technology, especially ELINT technologies, which monitor emissions from various satellites, spaceborne ELINT capabilities would help in identifying all these troublemakers and probably remove them, shut them out, or make them disable their functions. I'll stop here. Thank you.
Rajan mentioned important capabilities that in the international space community we rely on to understand the use of the space domain, including publicly available and privately available space object catalogs. And because of the disparate nature with which those observations are made, there are real issues of trust, of how we describe where satellites are, and whether to believe a foreign piece of advice using observations created by a system that you aren't familiar with, how you should use that to act sustainably, perhaps to avoid a collision in your own operations. I wanted to give Shan and Emmanuel a chance to comment on that same issue if they'd like to, cases in which pursuing a more secure space environment is one that challenges sustainability or safety. I might add, in documentation from the United States Space Force, if we stay on that particular example, but I might argue they are not unique in military organizations in the space domain. The Space Force in particular uses a phrase called responsible counter space campaigning. And by their definition, that means pursuing the abilities to damage, destroy, and degrade satellites from adversaries around the world or space-based systems that depend on satellites in such a way that doesn't damage the environment, perhaps not creating long-lasting debris. I think that's a direct challenge to sustainability and safety, but I'm curious if you agree and wanted to shed some light from your own perspectives.
Should I give it a first go? Yeah, I think so far in the context of our project, the pursuit for space security just sits in contrast with the pursuit for space sustainability. But of course, hope to be proven wrong. Of course, then it will be more hopeful. So I guess a very prominent examples is that when states pursue space security, for instance, counter space capabilities, we have seen in the past that anti-satellite tests just have a direct negative implications on orbital sustainability by creating debris clouds. So these are very direct examples of when states are pursuing security, they likely pursue counter space capabilities that come at the expense of space sustainability. On a more indirect level, we see that when states pursue security, a little bit of a broader approach to security, that means they see their satellite infrastructures as strategic assets. Here we see increasing close coordination between state and private actors in order to sort of protect their satellite infrastructures as critical strategic assets. So we see, for instance, in the US, now there is increasing entanglements between the Trump administration and the Starlink satellite constellations. So when states have interest in developing or protecting their satellite infrastructures, they tend to work closely and perhaps be a bit more lenient in allowing the operations or the installations of satellites of their private actors. So in that consideration, we do see that increasing pursuit for space security facilitates more coordination or strategic alliances between state and their private actors, which then might allow the uptake of more number of satellites in the orbit, which then comes at the expense of orbital sustainability because of congestion, more debris, more fragments from space missions. So I guess if we take a step back and we think states pursue security, this might help them to achieve sustainability on a national level within their national regime, because this is to protect the long-term continuity and operations of their strategic assets. But it adds negative implications to space sustainability on an international level, because then it adds to the overall number of debris or severity of congestion. And of course, when states pursue their national interest, this overall lead to fragmentation, international fragmentation or global fragmentation. Alliances drive global polarization. This all cause negative consequences to successful international negotiation, which we all need very much at the moment. So I hope I bring in a little bit of this social and political science perspective to how we should unpack these entanglements between security and sustainability.
Okay, thanks. I'll be next. It's great. We have a great diversity because I have a totally different angle to the question. I want to bring first one keyword, which is very much in the trend in Europe, but maybe also in the US, is the word resilience. And I think this tension between security and sustainability all gathers in a concept of resilience, and we need to have more resilient space system. And that can go also in the link that you of shielding, that I would say you need to develop the technologies so that your spacecraft can sustain impact from objects because you have more debris, but resilience to cyber attacks. From my understanding, space assets are not very safe in terms of cyber security, and there is a huge effort to be done. And I think we are all learning a lot. And because of course it's very critical because you have like private and public assets, and you can have a satellite, it can be hacked also by a private person. And I was having discussion this morning with someone from the company CISEC, which is a Swiss company for cybersecurity, and mentioning that there was a person who managed to hack a satellite with only $300 worth of materials. So I think there is a lot of, I would say, a way to be better, and also resilient, also that you need also to be able to repair those space assets in space. So I think there is a whole like range of technologies, of capacities that can be developed also to ensure resilience that will serve space security and space sustainability. Then there is another angle, and I think which is interesting, because we saw indeed there was a few anti-satellite tests. People talk about the space war, but we also need to consider that space is a place where you have some infrastructure, space-based infrastructure that supports security in space, but also on Earth. And for the military, they also see space-based infrastructure as a support for their operation on the ground. Should be for intelligence, communications, support for any movement and things like this. So they are highly dependent on those assets, and this is why you need, maybe you would want to jam play an area where you want to perform an attack or things like this. But it means also, on the other hand, you don't want to I would say maybe to attack a satellite and create a huge cloud of debris that will then endanger your own asset. So there we come, because it's a global command and it's a global space. And if you attack your other, like if you do really like a physical attack, you can endanger the whole area. So that's why this is very specific, and I think the people that wants to use the space field, they are pretty much aware of that. And that will give me just a last thought, because so I'm not an expert, of course, in space security and military operation in space, but I also heard that people were considering also to develop some data centers in space, so space data centers, because somehow it's safer. And I was thinking, why is it safer to have a data center in space rather than on ground? And then I thought maybe it's because of this, because it's more difficult to attack a space data center than to attack maybe a data center on ground, because you know that if you endanger it, it's there, you're exposed, everyone can see who's doing what. So maybe there's this dichotomy that we see it as another place where people like would use it, and we talk about space security, but it's also because there might be a war in space, or actually it's possible that it's safe because it's there, it's open, and as it's very dynamic and everything's moved, you cannot act in space as you're doing on the ground.
Thank you, Emmanuel. I think it's a privilege to be in sort of an academic conversation in that we're not afraid to disagree with one another. And I hope that inspires some of our audience members online, which is a good segue to remind you all, if you're watching, you have an opportunity to ask our guest panelists some questions yourself. At the end of our session today, we'll dedicate about 30 minutes to some of the Q&A we've received from the online webinar system. I see a few questions coming in already, so please take that opportunity if you're interested. I wanted to direct our conversation back to the ITU, which is hosting us so graciously today. As many of our online guests may know, the ITU has a certain mandate. to efficiently and economically administer a radio frequency spectrum sharing system. And if we notice from our conversation, there are some words missing from that mandate. Even though they're administering a sharing system for space services, they're not mandated to do so with space security or space safety in mind. And this is a kind of coarse example. If you're participating in the international coordination system at the ITU and you're a space services operator, you may even be able to achieve protections from the ITU or an ITU satellite network where you can send and receive certain frequency bands from a certain orbital position at the exact same orbital position as another member state from around the world. Of course, if there are two satellites in the same spot, they're at a great risk of physical collision. So there are times in which the mandate is pushing and pulling against some of the other imperatives for safety, sustainability, and security that we've been talking about. And so I wanted to ask the guests, and I think for a lot of these questions, you can really just chime in if you're of interest. If you could please sort of tell me more about how, as an international operator or international system, we can balance that push for efficient and economic access to space, especially these valuable combinations of spectrum and orbital parameters, with the longer term imperatives of safety, sustainability, and security that we actually know quite well in our research community. I'll let yourselves unmute yourself if you'd like to give it a shot.
Can I go ahead?
You may, Rajan, but you're muted again.
The ITU's mandate as the allocator of frequency spectrum is well known. Again, I'll go back to the days when there were few satellites around, and most of the contest was about the geostationary orbits, where you had close because the land area is less, and every country wanted to have those satellites above their country, and hence there was a conflict in spectrum, etc. The issue is there is something called RF pollution. RF pollution starts with implementing transmitters and receivers. For example, the transmitter with extremely good stability, like for example, if you take the GPS, the waveform from GPS, it is stabilized by an atomic clock. And that is why we are able to, many of us are able to receive it simultaneously without any problem. Whereas when we go to low Earth orbit, again, low Earth orbit with agencies which were government run earlier, were following certain strict pollution control measures. Like the basic pollution means you are supposed to transmit only at a particular frequency, but no transmitter is pure. There'll be a lot of side lobes, which if they go above, beyond a particular level, can interfere with other satellites. Now that we have thousands, now 10,000 satellites in low Earth orbit, ITU might have to review the frequency allocation methods and also enforce more stringent stability standards on the operators. Okay, once you have more stringent standards, the basic concept, the cost of the transmitter or the system goes up. And once the cost goes up, the other issue of sustainability of this industry, I'm now talking about sustainability of the industry, that is in terms of economic terms, also gets affected. So there will be an optimum number somewhere where you can sustain this with the RF spectrum allocation, because RF spectrum is not infinite. And as number of users go high, the channel spacing between them has to come down, and so hence strict control on RF pollution is important. So ITU has to do this, and ITU has to do this now with taking into account the orbital parameters as well. because the hence, and it's not a very easy thing to do. It is quite complicated mathematically. So very complex simulations have to be run in future in order to allocate reasonably good frequencies which will sustain. I'll stop here.
Yeah, I might add that in order to pursue an efficient and economic system, the ITU is encouraging by design what I would call, and these are my words and certainly not those of the organization, they're pursuing the healthy densification of the near Earth space environment, a distribution of those, as Rajan mentioned, inherently limited natural resources, the radio frequency spectrum itself, but also what I would call orbital real estate in the most popular orbital regimes. And pursuing that densification has unique challenges that might go back and affect the economic viability of using the environment, as some of our other speakers mentioned. So I wanted to give them a chance to comment on this as well before I ask for some a specific example with a bit more context. Shanna or Emmanuel, if you'd like to, please.
All right. Yeah, I can give it a try. I think it's just like when we have the climate crisis and experts sit together and start identifying that, hey, we need a threshold of 1.5 degrees warming and not to cross these thresholds, right? So when it comes to this problem that Thomas, you have put forward, I think on one hand, I understood that we have to pursue, the ITU mandate is to pursue economic efficiency of this frequency allocation. But on the other hand, it could cause space security or sustainability challenges in the orbit sometimes. So how do we balance that? Yeah, coming back to this socially constructed concepts, right? I guess it is important for the ITU to try to put together different stakeholders, different actor representatives, and this is a huge undertaking. It's not something that we can just do overnight, of course, but to put together these different stakeholders and actors involved with different interests and with different challenges at stake, and perhaps identify new indicators or conditions or thresholds, at which point we have to cut off that this is the point that we should no longer just assign a frequency because of efficiency. You know, this could work back in the days, but then we are living in a different time where satellite activities are just booming so quickly that it's beyond what the international regulatory framework could cope with. So perhaps it's time to then change or adapt this principle a little bit. Economic efficiency as far as certain conditions, on the conditions of what, and those different stakeholders with their different needs and interests and perspectives coming in to jointly discuss. This is when we think with their space traffic information and the data that they share, this is where we would flag that it could bring some risks, collisions, or whatever, that to jointly identify new conditions, like this is the cutoff point, this is how far we can go. And I'm not saying this is an easy task, but it is something to be considered. Yeah.
Emmanuel, if I may sort of point a question directly towards you, both Rajan and Shan did a great job of describing some of these concerns on a system level. All operators working together. And the ITU by design is a collection of member states and a forum for discussing shared issues. But in your work on the space sustainability rating, you have a great vantage point into individual space mission operators, who themselves, I would argue, are balancing concepts of economic efficiency and space sustainability. And I wanted to ask you if you could give us any examples from your time working on the space sustainability rating or in any other experience with spacecraft operators where they're directly balancing economic efficiency and sustainability values. That is, in order to pursue behaviors that they deem to be sustainable, they're going to lose out on revenue if they're a commercial satellite operator, or they're going to lose out on other mission capabilities, perhaps if they're from civil science or the military sector?
Yeah, thanks. That's a great question. It's true that DSSR, the aim of DSSR is really to acknowledge positive behavior and good behavior. So it's more like a carrot effect that you try to push the people to be more responsible. And in that area, we do see that operators and, for example, large constellations operator, they know that outer space is their play field, let's say. So that's where they act and they do their business. So actually, to be sustainable is not for them to lose and to be less economically efficient. It's for the survival of their business, because they know that what is at risk at the end of the day is their own business, because the big pending risk is that if you're not behaving sustainably, you can have the chain effect or Kessler effect, that you have the snowball effect, that you have one collision that will bring to another, and so on and so on. And I think this is essential, and that goes both for the physical and also the emission part, because if you lose also contact to your satellite, or you have control of your satellite, then you go to those aspects. So I would say that's one part. And the other part also is that nowadays companies and large companies, especially the ones that are on the stock market, they need to showcase compliance to the stock exchange. Sorry. They need to showcase compliance to certain standards, and especially for corporate social responsibility and environmental and social governance to their shareholders, to their governments. So they need to show that they are taking actions, and ask also for third parties to check at those aspects. That's where, for example, SSR can come in place for this reporting, both for the shareholders, but also for the investors that are also looking at this. And such as anything which is related to climate change, also with the space environment, it's also it's also for the viability of the business that you're doing that. If you're a true capitalist and you're still channeled by this, it's also for the survival of your business. And I think in that way, the both it goes in line.
I could have mentioned this in the introduction, but when I'm thinking about these topics, I'm doing so from the perspective of my technical training. And I'm an astrodynamicist from, specifically, I'm focused on the geosynchronous orbital regime, which drew me to the ITU for its historic regulation of that space. And the ITU is not the only organization thinking about the health of those popular orbital regimes, and especially geostationary orbit, which I'll refer to as GEO from now on. The Interagency Debris Coordination Committee, which is a collection of civil space agencies around the world to discuss issues of mitigating space debris, have put forward recommendations. These are in the early 2000s, and in 2007 were endorsed by the United Nations General Assembly, about particular guidelines that you could take to reduce the space debris population. And some of them, I think, are directly challenging economic efficiency. So I wanted to pose one to the group, and I'm really curious about some of your responses to that. So one of the recommendations in popular orbital regimes specifically, that's GEO, and for the audience who doesn't know this, the most popular orbital regime is just above the upper reaches of our atmosphere in low Earth orbit. If you're in one of those two popular domains, you should remove your space asset at the end of its operational lifetime, when you have a little bit of on-orbit propellant. There's a little bit of gas left in the tank. At the tail end of your mission, you should, if you're in GEO, pop yourself up to a higher altitude where your likelihood of collision is near zero with the rest of the population. Conversely, if you're in LEO, to use a little bit of fuel to lower your altitude and burn up in the atmosphere and remove yourself from the environment in that way. In both cases, that's asking satellite operators to expend what is often described as the currency of spaceflight operations, fuel, in order to be more sustainable. And it is that same fuel that those satellite operators could use to extend their mission within those popular orbital regimes. So in GEO specifically, the amount of fuel needed to raise a satellite's altitude to the recommendation of the Interagency Debris Coordination Committee is about the same as the amount of fuel needed to station keep or stay within the GEO belt for about 4 to 6 months. And for different states around the world, 4 to 6 months of operation time in GEO has different value. For commercial operators, that could be a sizable amount of revenue they're interested in generating, as opposed to following these non-legally binding, in most cases, guidelines from IADC. And in some cases, we can find that even though these rules are non-binding, they can contribute to some changes in behavior. Some satellite operators after 2007 have changed their practice to retire to the graveyard orbit, as it's described in spaceflight operations, more often than they used to. The same operators making similar decisions about what to do at the end of their operational lifetime. Shan, how are we supposed to convince economically driven satellite operators who can count the number of dollars they're losing to participate in sustainable spaceflight behaviors?
Yeah, that's a tough one, right? Yeah, assuming or in the context that these expectations remain voluntarily based, it's obviously very difficult to motivate operators to do that. But I think they should also see that achieving sustainability, even though when it is not legally binding, as something that legitimizes their activities when the sustainability debate is getting more intense. So they should see this as something more than just a economic transaction kind of value, but a broader value in terms of legitimizing or gaining social licenses of, conducting space activities in a responsible and sustainable manner. But I also do think that the kind of discourses or policy framings that we can read about or they get exposed to have a big role in this. If policymakers or regulatory bodies could start reframing or taking a broader approach to how they present the concept of sustainability in the international arena, in the international organization bodies or at the UN meetings, this would overall shape a different trajectory to how the industry or the international space community as a whole to talk about sustainability. Of course, right now, the definition of the space sustainability remain very much economic oriented, right? The long-term sustainability of or the continuity of outer space activity. So it is still very much economic oriented towards operations, but not so much on the environmental integrity of the orbital environment itself. So I do think that how the policy discourses are being put forward to the international space community makes a difference. So policymakers, they are making these documents or leading these debates in international policy arena should be more proactive in constructing a new vision of sustainability. And that can, overall create sort of industry expectations or social expectations that is not documented, or it is not codified in papers yet, but then it creates a new set of expectations, especially when we consider this rising number of satellites. So hopefully this helps.
Oh, very much. And this is why I'm so pleased to have a social scientist in the room in you, Shan. But also in general, when discussing these issues, especially in the international community, we need different academic perspectives for many reasons. And one is in the room with us right now, this mention of this social license to pursue new activities in a denser or more congested space and environment, or precluding new rules and new recommendations that don't exist yet because they're not needed in a not saturated environment. And to hold on to the geo example, the recommendation to remove yourself from a geo altitude and go up to a graveyard or super synchronous altitude is way older than 2002, the first draft of the IADC guidelines, but they're rather theorized in the late 1970s. And right then, when that was published in an academic paper by Luboš Perek, a Czech astronomer and a leader in the United Nations Space Affairs, we saw actors around the world following that guidance. And arguably, it was not to lower the likelihood of collision, because the likelihood of collision in the 1976 geo environment was very, very low, but rather to signal to the international community that that actor, and it was Intelsat, was committed to the idea of pursuing more sustainable practices, even well in advance of needing to do so. And I think we see some states, not companies, but states doing the same thing now in advance of open-ended working groups in other corners of the United Nations. Of course, here at the ITU, we're sitting at a specialized agency of the United Nations, but we are not alone in thinking about the shared maintenance of this international domain. Okay, but I want to make sure I get a chance to ask a few more of these questions before I address some of these good questions streaming in from the audience, but don't be shy if you haven't submitted your question yet. There's still a bit of time. But Rajan, I promised to go back to your example about those brake inspectors, because we were just talking about a few non-legally binding recommendations, which I would argue do reign supreme in the international discussion of space sustainability and space safety. But some individual states can and have encoded these values of space safety and sustainability into their own state laws or their own state regulations to encourage commercial actors in their own state to change their behaviors and be more sustainable. Of course, under Article 6, I believe, of the Outer Space Treaty, states are responsible for the non-governmental activities that occur from their state in the space domain. So I would ask you to flesh out that example of the brake inspectors, perhaps given your knowledge of the Indian government in particular, for the space domain. Who are those verifiers? With what authority can they inspect space assets before they get to the space domain, while they're in the space domain? And as we think about the sustainable nature of long-term activities, we also need to think about post-mission activities, especially as some of them threaten populations here on the Earth's surface through falling space debris. But Rajan, I'm curious to hear what you think.
Yeah, thank you. India has just started out. The new Indian space policy has been announced about a year back. And we have an organization called InSpace, which encourages the private parties to participate. So there are going to be few launches soon. For example, we had recently an experiment called SpadeX. You might be knowing that we tried to dock 2 satellites, undock them, etc. And these were manufactured by a private agency. But this private agency, I'd been personally to this place, had inspectors from the Indian Space Research Organization testing out, helping them to integrate and put them together. Now, this is possible for a few, the number of satellites that are being manufactured and put together are less. But if, like the SpaceX, thousands of satellites are to be manufactured, and if you need there are two types of agencies. One is the design certification agency. Second is the inspecting agency. That is, the inspection agency's job is to see that the product is manufactured right. This I am taking a parlance from the civil aviation. We have inspectors in aircraft factories who sit there and see that, and they are being paid or looked after by the consumer, which might be the Indian Air Force or the civil aviation authorities, civil aviation users, because they want to be sure that they're getting a quality product. So this is where the problem starts. The problem starts when you have to have so many more production agencies, so many more independent producers or designers of systems. So in our country, the government supported government organization will lay down certain rules for the design and also offer. See, the problem is in a country like ours, the small scale industries have a tough problem in finding even test facilities, because the space environment is temperature, vibration, vacuum, all that you need to test them. So we are setting up facilities to enable those manufacturers. That is, I'm talking about small and medium manufacturers, business enterprises to use these things. But finally, in fact, this is the point I wanted to raise here. In the civil aviation parlance or in the aeronautics parlance, ICAV is an organization which lays down rules, and as an international body, and it has got the UN support. Down the line, for example, FAA it implements whatever is being commonly decided between ICAV and FAA. It is capable, or it is not only capable, it takes the responsibility for implementing those standards in the US. And we do have our own DGCA organization, which implements for the civil, and another organization for the military. This is missing in the space industry. When I started working for and discussing space industry, there was no ICAV. So we have a regulator called ITU, which does a little bit, but more than that, in specifying the quality of preparation of the satellite in terms of the components to be used, the environment it should withstand, design clearance is not heard of. But fortunately for us, in the Indian Space Research Organization, we have groups which do this. And right now we are extending support to the small and medium scale industries. But in the long run, this is a question. So it's very important across the world to have ICAV like instead of Indian International Space Organization, which will lay down the rules and control. This is very essential. I'll stop here. Thank you.
This is a good place to acknowledge we're really met with great diversity on this panel in terms of what states we're most familiar with. So Rajan, thank you for that perspective into the Indian state. Shan or Emmanuel, if you have familiarity with how other states have encoded some of these space sustainability recommendations, I think the audience would be curious to hear from those perspectives as well.
I'm not aware of the other states. I've not done work on that, but I'm quite sure all the advanced countries will have these things in. For example, especially for launch capabilities, FAA definitely supports the STAR, the company SpaceX company is being extended with support from FAA in order to have reliable launches. Regarding, for example, if if a Starlink satellite is completely qualified to be in space, what I call as space worthiness. I searched for this word phrase, space worthiness. Unfortunately, it is not there on the net. And whenever it is there, it pertains to human space flight only. Only when a human life is involved, they are talking about worthiness. What I am trying to bring out here is, if a satellite is launched which is not worthy, it can fail and collide with another satellite and create debris. And ultimately, this can have a multiple effect. If more and more such satellites, which are not fit enough to be in the space, or manufactured by because we don't have control on all the manufacturers, because cutting corners would come in, so many other things will come in. So we need to have this in order to achieve a sustainable space. I'll stop here.
You may have trouble finding the term space worthiness. I think that actually is an interesting one that we could ingest into the mission authorization framework. But states are required to determine whether the assets from their commercial industries meet their requirements, and it's their requirements described and developed on their own for spaceflight, because it is the states that would be held liable for any damages that occur because of those space activities, such as collisions between objects in space, but also re-entry risks. So I did want to give one chance to, I think maybe perhaps Emmanuel has some experience in this space, especially when thinking about the diversity of different states represented by mission operators pursuing SSR ratings.
Yeah, so it's true that actually it's the responsibility of the states to implement in their national laws those safety or sustainability standards. The goal is really, so first it started with some soft law tools such as standards or guidelines. I would say for space debris or space sustainability, the most prominent might be the space debris mitigation guidelines developed by the IADC, the Interagency Debris Committee, which is really from like different agencies, the US, China, Europe, Japan, and so on. India, also ISRO is represented, where actors agree. And then we see that such documents, they are cited in some national laws. Or also the ISO standards has a strong role there, because some of those recommendations are also in ISO standards, and ISO is also well recognized, so then it's also international, so then it can be applied. However, in terms of space laws, not all countries have a space law, but more and more countries have. And I think there they get a great support also from the UN. So I think it's a great tool. For example, Switzerland is currently doing a consultation on its own space law. But then you have countries such as Liechtenstein, who already has a space law. In Europe, the French space law is one of the oldest, from 2008, because France, of course, is a launching state, and there they have some very strict requirements. And that's what is interesting is to really see how those soft law tools can be then incorporated in more hard law. This is my personal opinion, but I see that the most effective way to have I would say regulatory, so mandatory and binding, I would say rule for operators is really through a national regime today, and international cooperation, either through formal groups, IADC, but maybe more industry-led groups, or such as the Space Safety Coalition, Space Data Association. There's the Net Zero Space Initiative, shows also what are the best practices, the best standards that can be then translated into ISO standard that can be then used for a national law when you're looking for really like practical, technical ways to implement those big principles. So I hope this answers your question.
Yes, very much. Thank you, Manuel. As promised, I wanted to turn it over to the online questions from audience members from around the world. Don't feel discouraged from submitting new questions. I'm thankful for the career staff here at the ITU for helping me collate and collect these questions. Thank you. I also might combine a few of these questions, so you may not hear them verbatim, but I hope some of the main issues can be addressed by some of our panelists. Shan, this one I wanted to address towards you. You mentioned the responsibilities of human decision makers in Earth space sustainability, and social licenses are in the literature granted to people and by people. And so this question could sort of challenge that paradigm. They ask online, how can emerging technologies such as artificial intelligence or non-human decision making contribute to enhancing space safety?
So how can the incorporation of AI technologies help with addressing space safety?
That was the question. And if you think that it could also hurt space safety, I want to give you the liberty to answer in that way as well.
Yeah, thinking from technology potential, and of course, I have learned from my colleagues who come from more technical and engineering background that AI, incorporating AI into detecting collision risks to better manage space traffic. What I understood is that it can be very helpful in more efficient way of detecting and managing in these aspects. But of course, yeah, as you pointed out, right, Thomas, identify what should be flagged and what should be a warning. You know, this perhaps is something that also requires a human perspective or human intervention, especially because defining these thresholds is something to be constructed by taking into consideration diverse perspectives, diverse interests. So when we say safe for whom, sustainable for whom, right? So unless AI technologies can do this in a ethically sufficient way, then we could actually rely more on them. But I don't think at this stage that we are there right now. So in order to train these machines, we need human intervention to be part of the discussion. So yeah, a discussion we tend to have with the technical experts is that can we identify indicators that considers or take into account ethical considerations? When do data become information? When do which kind of information become actionable, become important to be tackled in a timely manner? So we are still, I believe we are still in the phase of discussing and identifying these indicators. So perhaps this to fully rely on AI is something a bit still on the horizon, not so near in the future.
I think that what's challenging about AI applications in space is that there is great opacity with how some operators are deploying these technologies and how some might do so in the future. So one question here is along that same theme. Are there any innovative solutions being developed to address the problem of mega constellations and their impact on orbital safety? So I might add that the largest constellation in the history of human activity in space is the Starlink constellation mentioned by Rajan earlier. And in that case, SpaceX has advertised that Starlink uses automated collision avoidance. That's AI-driven algorithms to reduce the probability of collision, not just between Starlink satellites, which is easy to avoid, but between the growing number of Starlink satellites, upwards of 8,000, and the rest of the satellite population. The public does not know the nature of that algorithm. SpaceX has not released it, and they're certainly not required to. And there's also never been a collision between a Starlink satellite and any other object, despite a few well-known close calls between allegedly a Starlink satellite and the Chinese crewed space station, and similarly with an ESA mission. I really am curious, Shan, about your use of the phrase social license here. Do you think that SpaceX has a social license to sort of earn credence for their deployment of an AI system that has never led to any collisions when we don't really know that much about that system? To add more color to this, we know little hints every once in a while. So the SpaceX has submitted comments to the FCC, the U.S. IT administration's notice of proposed rulemaking, and they've told the community how many automated collision avoidance maneuvers they have performed. And it's great numbers. They are, if we trust those comments, they are performing a lot of maneuvers when they certainly do not have to. But do you think that doing so gives them that social license? Is it possible to leverage AI-driven algorithms for the social license needed to contribute and lead space sustainability and space safety conversations internationally?
I think from what I'm hearing at this moment is that yes, the AI application might technically help to better maneuver risks for a collision. So the integration of the technology into the system might indeed help to better manage this more effectively and efficiently. But from our project's perspective, or from my perspective, this is not the reason to legitimize their activities. So we have to try to distinguish two issues. One is it okay to deploy this technology? Another one, because they deploy this technology, does it make them gain a so-called social license? Is it okay then they deploy so many satellites in the orbit? For the second part, from my perspective, the answer is no, because from our Planet Stewards project at the moment, our PhD students are looking into the case of Starlink. And what we see that among the many issues that we identified includes that we found a lot of mining activities happening in Congo with social and environmental implications. And this mining goes into the manufacturing of satellite constellations. And this is not well reported. This is not easily read in the media. And at the same time, of course, we also see that the deployment of the Starlink services pose such big consequence to the case of Ukraine. For instance, the Trump administration and SpaceX sort of put out a threat to discontinue that service on the condition that Ukraine will hand over some mineral resources to the US. This is very quite sensitive at the moment. I don't want to talk too much about that, but I want to say that if we look at this broader sustainability criteria of space activities, this big monopolization of the orbit and the occupation of the orbital environment is not okay. So we have to be very attentive to how the company is framing what they are doing in order to legitimize their activities. So yeah, I will stop here.
No, thank you for those remarks, Shan. You're making me appreciate my moderator role, because then I'm not forced to ask or answer these tough questions. For those watching, there is certainly not yet literature, as far as I'm aware, on the social license of AI applications in the space domain, but maybe we have some authors who are listening in now. Emmanuel, I have a question for you from the chat. One audience member is curious about the methods to eliminate wasteful satellites, presumably derelict satellites at the end of their operational lifetime. Deorbiting, as I mentioned earlier, or removing low Earth orbiting satellites from low altitude orbits is certainly one method. But are there others that are less impactful and minimizing threats to the Earth and its atmosphere? I assume it is an economic cost to find new ways to eliminate wasteful satellites that pose these risks. But do you have any examples of other technologies that are a part of this conversation?
Yeah, I'm thinking. So here the question is not to talk about deorbiting, but other solutions. Is correct? Okay. So I think in terms of course, so there is also a whole like discussion or trend also that looks also at applying circular economy mindset, also circularity to space assets. And in that way, at the end of the life of a spacecraft, you could consider also to repurpose your spacecraft for another use or another function. So one way would be, and this you can see, like you can repair or recycle, refuel in order maybe to extend the lifetime. You mentioned fuel is the important part. If, for example, your satellite doesn't function anymore or is not fulfilling its purpose because of this function, instead of deorbiting, you might be able to come to repair it. And of course, recycle, like in the long term, that you could go and retake some of the materials to recycle also. This is one part. Another part is also to have this like circular economy thinking when also from the design of your satellite. And I think the technologies that we are developing nowadays shows that you could also repurpose the payload, reprogram the payload for another mission, also in order to upgrade it. This also is a way also to it's not to eliminate a wasteful satellite, but to repurpose wasteful satellite. And there, I think with what we call the quantum satellites or quantum computing, you can really repurpose, reprogram your spacecraft. And there is already one quantum satellite that was sent by the European Space Agency, and this is one of the big parts that is behind. So this agility that you can have with the spacecraft, and also the possibility to have more payloads, more type of payloads into a spacecraft that would also have those different applications. Because usually you have one or two payloads for one operator on a platform, but you can also have more, like shared platforms. And also the fact that now we can upgrade, maybe also have satellites where you can, let's say, reboot your satellite, reinstall some of the software, and in order to enhance also the capacities of some of the payloads, and also to increase those capacities while still using the same hardware platform, but still like upgrading the software part. So that might be also ways, apart from deorbiting, technologies that are developing or being tested, that also people, because here we have people from the ITU that needs also to anticipate those applications. And I think especially because you provide maybe a license for a specific purpose, but then the same satellite might after 5-10 years have another purpose, and then you need to maybe rethink also the licensing in this aspect.
Thank you, Emmanuel. I hope the gentleman who asked the question that they're happy with that answer. And there really are a lot of technologies being not just theorized, but demonstrated to more actively control the space debris population. Rajan, there's a question from the chat that I think is relevant to some of your earlier remarks, which is about the difference between thinking about space safety with respect to human missions or crewed space stations versus the vast majority of space objects, which are uncrewed or robotic missions. I'll add some commentary here myself, which is at the sort of the earliest era of thinking about collision avoidance. We don't know in the broader space object population how satellite operators employ risk tolerances? How likely of a collision must there be in order to inspire a voluntary collision avoidance maneuver? But one of the best and earliest examples of that risk tolerance is that of NASA and the partnering agencies, the European Space Agency, Roscosmos, and JAXA on the International Space Station, because of course there are humans on that spacecraft. Now operators of robotic missions also publish their risk tolerances, even though of course a satellite collision between two robotic satellites will not directly result in the loss of human life. I think folks know well from popular literature, including dramatization in the blockbuster hit Gravity, about the possibility of fragmentary debris threatening human life. So Rajan, back to you. Since you mentioned human versus robotic missions, how should we think about that difference? Perhaps from any examples you have from the aviation community, where of course there are crewed aircraft and robotic aircraft.
Yeah. The crewed mission needs to have a very reliable system in terms of safety of the human being. Okay, even there, the most important functions are keeping the environmental conditions to maintain the conditions for his life, the life of the astronaut. But whereas in an uncrewed aircraft, uncrewed spacecraft, in general, the system implementation doesn't pay attention to two important aspects. Again, the only way a robotic or uncrewed spacecraft will, on failure, affect others is if the trajectory control is lost. So one of the most important things is on all or most of the uncrewed, which are basically 99% of the spacecraft that we are talking about, we should have a segregation between what is controlling the trajectory and what is controlling the mission. For example, the payloads, if the payloads fail, it is a loss to the company, so they will take care. But if the trajectory control system fails and this starts maneuvering uncontrollably, then it is going to damage other satellites and the overall traffic management system. So this is very important that we have new architectures looking at, again, I am drawing this from a aeronautical perspective. In the aeronautical systems, for example, there are two major systems, the avionics system, of course, propulsion system is there. Propulsion system and flight control system are generally multiply. They have a lot of redundancy. In fact, today when you fly any of the big jets, either Airbus or Boeing, those are quadruple redundancies in the to maintain the aircraft control system. So you have never heard of something fail. Of course, you had a failure in the 777, and that was very clearly attributable to certification issues. The Boeing did some change without informing the certification authority and got into trouble. And that's a big economic loss also for them. So it shows. So in fact, that AI question also is important. Using AI for collision avoidance, it's not that they have to publish a paper on what kind of AI they are implementing, but they have to convince some certification agency. We do that all the time without affecting the proprietary rights of that particular software or algorithm. We can get it verified by certification agencies and still keep it going. So it's very important that we look at the satellites architecture in terms of new system design, because we are going to have more and more satellites up there, and the collision avoidance is very, very essential. And coming to talk about the Starlink's AI control of collision avoidance, it has not been proven with non-cooperative satellites. All the satellites are cooperative. They talk to each other, so they know where they are, and it might be it will work. But if you want to do collision avoidance using AI, definitely we are not ready, as Sean pointed out, because that reliable AI system is still not been established. Thank you.
There's some very interesting comments in there too about sort of the nature of how satellite operators around the world deal with the collision avoidance problem. Certainly some satellite operators are very communicative with one another. We, in the astrodynamics community, when we model the risk of collision, we often use the value 0 to describe the collision risk between two satellites of the same operator. Of course, two satellites of the same operator could collide, but we understand when modeling the problem that that risk is very near 0. Okay, I want to be cognizant of the amount of time we have left, so I'd like to give the chance for each panelist to offer some concluding remarks. Just as a bit of a warning for all three panelists, I'll do that in the order in which I introduced you: Shan, Rajan, and then Emmanuel. And my question is really about how audience members should look at the news in the coming months and years regarding the saturation of the near-Earth space environment and its popular orbital regimes as it relates to improving space safety, security, and sustainability. I think the benefit of hearing from experts is to offer a bit of a filter. There is a lot of news in the international space community, but what should our audience members look for if they want to be a better subscriber of some of these issues? What are some things you're looking for in the near future when it comes to these pressing issues we've chatted about today? So Shan, I'll give it over to you first.
Okay, thank you, Thomas. I think, yeah, for the international space community, when it comes to these problems, and especially this broad term of space sustainability, I guess following today's discussion, it is certainly important, and it would be hopeful if we sort of adopt a more critical eye when we are exposed to news on space activities development. In that sense, we have to know what is presented to the public in the news or in the policy domain. These are framings of what space activities should be, what sustainability should be presented to us. So it is a question of who is interpreting those concepts, what are their interests, what are their rationale, and for what purposes. So our approach to these issues in the context of our project is always be very attentive to this multiplicity of actors with differing values, a lot of times conflicting values. Which is why Earth space sustainability challenges is so complex. So I think if we adopt this more critical approach to filtering this news, it also allows us to be better at distinguishing what are the pros and cons of those activities? Is it in terms of environmental or the social or the security dimensions? Are we talking about just the sustainability in space, but then it is disintegrated from what is happening on Earth, or is this now a more integrative or comprehensive approach? So yeah, I think I will stop here. If there is more, I will add later. Thank you.
Thank you, Shan. I often describe this as sort of like a what to watch. So Emmanuel, what's there to watch in the global community on these issues?
So I would say definitely we need to watch for any practical ways to do some space traffic management. I think we didn't talk too much, but also that goes, I think, with the overall like architecture on how we want to manage space. We need to have rules of the roads. We need to have clearer framework I think in the question, someone mentioned the link between space traffic management and air traffic management, which we don't have. So I would say there we really need to look what does the operators they need, the people that are sending the satellites, what could be the tools, something practical, and maybe to be innovative in terms of governance, how we can do this. I don't have the solution, but at the end, we really need to have something that works. I think this is most important. And also to invest the money in that. I think a lot of people have good ideas, but at the end, it's also about investing the money to do that. Yeah, I would say that would be maybe my call for action.
Thank you, Emmanuel. Rajan, I'll pass it over to you. Rajan, you may be muted this one last time as well. One more try. I still can't hear you, Rajan.
Yeah.
There
Can
you
you
go.
hear me now?
Yes.
Yeah. It was a good summary by Emmanuel. She talked about air traffic management. In fact, I want to add one interesting question. Basically, what we are trying to do now is all these days we didn't have the satellite populations density that we are having now. So what has actually really happened is we have numbers increasing. There is the equivalent parlance in the civil aviation. Just to learn a lesson, not to implement the same thing. When the traffic increased, they have brought in a new concept called reduced vertical separation minima, or VSM. That allows for a reduction in the vertical separation between two aircrafts in certain airspaces. So they made it from 2,000 feet to 1,000 feet. This is because this is required for sustainability, because you need more aircraft and the traffic is going up, and also to save fuel, etc., many things. So, but then this is achieved by certain other regulations. They said each aircraft should be equipped with a pressure sensor that accurately senses the static pressure, that is the pressure altitude. And it should be dual redundant. And accuracy requirements are specified. If you meet RVSM capability, you are allowed to be in that space. Otherwise, you are going to have 2,000 feet between you, and you're going to waste a lot of things. Similar regulations derived out of technical simulations should be applied to the space traffic management. So the most important thing, of course, see the whole world is having the same problem. On the road, we have driverless cars, which have to avoid other cars and obstacles, and they're being automated with sensors, and sense and avoid is a most important activity that is going on, and millions of dollars are invested in that. The next one is urban air mobility. Urban air mobility, where unmanned vehicles are going to pilot you to your airport or wherever it is, because the congestion below is so high. Again, they have much more difficult situation to manage the traffic. We can apply a common approaches towards managing traffic on the road, in the sky, in the space as well. For this, we need more technology, more simulations, etc. I think I will stop here.
Thank you, Rajan. And with that, I wanted to take a moment to thank our guest experts. Thank you so much for joining us this afternoon to share your expertise with our audience. For those of you online who didn't get a chance to have your question answered, please know that you can come back to future episodes of the Space Connect series. We have exciting episodes planned. They release on about a monthly schedule. You can learn more by subscribing to the LinkedIn page or visiting the Space Connect website at itu.int/space-connect. And you'll learn more about future episodes and how to get more involved in some of these issues. It's really been a pleasure to play host for this episode, but I really couldn't have done so without the great support of my ITU colleagues from the Office of the Secretary General, the Radio Communication Bureau, and its Space Services Department. So thank you to all of you. Please, I hope to see you next month. And until then, see you next time.
And thank you, Thomas, for the great moderation.
Yes, thank you, Thomas. This was great.
Thank you.
Thank you.